Once again, a very good afternoon to everyone, and thank you for taking the time to join us in the Driving into a Sustainable Future with Electric Vehicles webinar, jointly brought to you by Singapore Polytechnic and the Singapore Green Building Council. My name is Joel, an engineer from the Singapore Green Building Council certification team, and it is my pleasure to host the webinar session today. For the benefit of those who just joined us, 2 CPD points are confirmed for SILA LA accreditation. CPD points are still pending confirmation for SGBC Green Mark accredited professionals or SGBC GMAPs. The PDUs for professional engineers and Singapore certified energy managers are also being confirmed. To facilitate the crediting of CPD points, professional engineers and Singapore certified energy managers are to provide your professional registration numbers in the Google Sheet via the link shown on the screen and in the chat box. The information will be passed on to the relevant industry bodies for their needful action after attendance has been verified. With the announcement of the Singapore Green Building Master Plan, or SGBMP, early this year, the built environment is set to see a paradigm shift in the way we design, construct, and operate. As part of the nationwide Singapore Green Plan 2030, the SGBMP aims to deliver three key targets: 80, 80, 80 in 2030, paving the way to a low-carbon built environment. With these goals in mind, the building and construction industry must accelerate its own sustainability objectives in order to support the nation's plan to building a greener, healthier, and more sustainable Singapore for Singaporeans. With buildings being the common denominator, the places we live, work, and play in must be constructed with green in mind. And construction organizations need to stay abreast of technology and innovations to meet the rising call for environmental sustainability starting from the work site. Other than the goals for the built environment, the Singapore Green Plan also comprises the use of greener transportation. The government has been taking steps to achieve the target of deploying 60,000 electric vehicle charging points by 2030 across Singapore public car parks and private premises. With Singapore looking to phase out petrol and diesel cars, all new cars registered by 2030 will have to be cleaner energy models. Today's presentations will cover the evolution of electric vehicles or EVs, in short, the impact it will have on infrastructure of new and existing buildings, as well as the challenges in face of escalating global demand for electric automobiles. Without further ado, it is my pleasure to turn the time over to our first speaker, Dr. Wang Hua-Qian, Specialist, Autonomous and Transport Systems from Singapore Polytechnic. Prior to joining Singapore Polytechnic, Dr. Wang was a research fellow specializing in the EV area for National Institution of Environmental Studies in Japan. Dr. Wang has also completed numerous R&D projects in recent years funded by EMA, MOE, and other organizations. Dr. Wang will now take us through the correlation of the SG Green Plan 2030 with EV adoption, an introduction of the evolution of EVs, major components, and charging standards, as well as challenges faced while promoting adoption of EVs. Over to you, Dr. Wang. Please turn on your webcam, unmute your audio, and share your screen before proceeding. Dr. Wang, please.
Thank you, Joe. My presentation is about the introduction to electric vehicles. Before I discuss the electric vehicles, I like to first recall the targets of Singapore Green Plan 2030 on electric vehicles. There are mainly three targets. The first one is to, from 2030, all the new registered cars must be cleaner energy models. The second task is to phase out all internal combustion engine or ICE cars by 2040, and all vehicles will run on cleaner energy by 2040 in Singapore. To achieve these two targets, the government has increased the EV charging points target from 28,000 to 60,000 by 2030. Then actually, this effort is not only in Singapore. Globally, there are more than 24 countries has proposed their plans to ban ICE cars and or implementing 100% sales of EVs, which include the countries like China, US, UK, and all the major European countries, and in Asia, Japan, India, South Korea, and so on. And among these countries, Norway is going ahead of all the other countries. They will ban ICE cars by 2025. The global selling of the electric vehicles also indicate the acceleration tendency of adoption of electric vehicles. You can see starting from 2015, the selling of the electric vehicles accelerated. And this is mainly because at this year, China come out some incentive to promote electric vehicles. So the China market increased very, very fast. By 2018 and 2019, China's EV market actually more than 50% of the world EV market. And in 2020, EU comes out the incentive policies, so the Europe market sharply increased. Then why are global demands for EV escalating? Mainly two reasons. First, to achieve the global climate target plan for 2030 and the carbon neutrality by 2050. The second reason is EV is getting more and more competitive compared with the ICE cars in recent years. Okay, to explain the first reason, let us see this picture. On the left side is the total greenhouse gas emission by economic sectors in US in 2017. You can find from this figure, transport is the largest source of the greenhouse emission. And on the right side is the data from a report, Smart Mobility 2030. In this report, it is indicate in Singapore, 20% of the total carbon emission is caused by land transport, and 70% of air pollution from motorized traffic. So that is why the adoption of EV is accelerated to control the carbon emission globally. The second reason is EV actually has made largely improvement in recent years. To understand this, first let us recall the history of the EV. Electric car actually is not something new. It has been around since the dawn of car itself. In early 1900s, electric cars were very popular amongst some American cities like New York, Boston, and Chicago. In that time, 1/3 of vehicles actually were battery powered. But after 1900s, EV declined. These are some pictures of early EVs in the late of 1800 and early of 1900. Now, why the after 1900, EV or electric cars declined, mainly two reasons. The first reason is the petroleum was abundant and cheap at that time. And the second, or maybe the most important reason, was the technology of gasoline-powered cars improved a lot. So the performance of ICE cars is much more better, was much more better than EVs. So the EV declined. By the time of 1930s, there were no electric cars to be seen. But decades later, some things changed. First, the oil price went up sharply after the 1970s oil crisis, and air pollution became worse and worse with more and more gasoline-powered cars. So the EV came back to the attention. By the time of 1990s, many major automakers come out their own EV models, and hybrid EV was released at that time. So these are some EVs in late 1990s. But most of these EV you cannot see them on the market today. Why? Because all these EVs use the lead acid battery or nickel metal hydride battery. At that time, lithium battery was very expensive, and all these EV, because the battery limitation, all this EV only has limited range, typically from 80 kilometer to 200 kilometer, and the battery lifespan also limited. And what very important, they were very expensive. Even after the subsidies from government, still very expensive. So they could not compete with ICE cars in both performance and price. But after 2010s, Tesla Motor comes out a series of new EVs and change the face of electric cars. And these EVs are faster and can run longer, much more longer than the EV before. So the success of Tesla's encouraged the other automakers. Then more modern EVs come out on the market. These are some examples. In Europe, we have the BMW i3, Renault Zoe, and so on. And in Japan, we have Nissan Leaf, Toyota RAV4. And in China, they come out the BYD, new ES6, and so on. These are typical modern EVs. All these EVs are very popular now on the market. Then, because now China is the largest EV market in the world, let us see some EVs sell on China. Look at the performance and the prices of them. Okay, these are the models of these EVs. You can see the range of all these EVs are higher than 400, typically from the 400 kilometer to 600 kilometer. And the power is very high. The fast charging time is within 1 hour. Fast charging time is to charge the EV from the zero SOC to about 80% SOC, the state of charge. Okay, these are the prices of this EV. You can see the prices is quite close to their ICE counterpart. Okay, in summary, EV has largely improved in recent years. The price of the battery and the whole EV cars sharply reduced, and the range largely improved, and the battery lifespan also improved a lot. And all the modern EVs integrated with the intelligent control and autonomous driving technology. That in addition to the much lower maintenance and travel cost, EV is getting more and more competitive compared with the ICE cars, and this tendency will continue. According to EV Outlook report generated by Bloomberg NEF, it is estimated that the EV market share will increase from about 4% in 2020 to 70% in 2040. Even no more new incentives policies from the governments all over the world. But 70% is still not enough to achieve our climate target. So to achieve the carbon neutrality target by 2050, more policy support is still needed to accelerate the adoption of EVs. Now I'm going to discuss the types of EV. Mainly there are 4 types. PEV, it is also called the plug-in EV, pure EV, or battery powered EV, or BEV. Second type is HEV, or hybrid EV. The third one is plug-in hybrid EV. And the fourth is fuel cell EV. Pure EV is the EV. It is purely powered by battery and electric motors. Pure EV has the simplest structure in all these types of EVs. Here are some examples of the pure EV, and all the Tesla's models, and Nissan Leaf, and BYD's model, and BMW i3, and so on. Hybrid EV. Hybrid EV combines a conventional internal combustion engine system with an electric propulsion system. Hybrid EV uses the internal combustion engine to power the generator, to drive the generator. The generator generates the electricity to drive the motor, to drive the vehicle. And also the generated electricity may be stored in the battery. According to the structure of the drivetrain of hybrid EV, the HEV can be divided into parallel hybrid EV, serial hybrid EV, and series parallel hybrid EV. The purpose of use the hybrid EV, of course, is to extend the range, because at the early stage of EV, the range is limited. And also use the hybrid EV can improve the energy efficiency, so can reduce the emission. These are the drivetrain structures of hybrid EV. This is the parallel hybrid EV and the series hybrid EV, and this one is the series and parallel hybrid EV. PHEV, or plug-in hybrid EV. The major difference is hybrid EV cannot be charged by using external power supply or power source, but PHEV, its battery can be charged by using external electric power source. The PHEV has the relatively larger capacity of battery, so it actually combines the advantages of HEV and the PEV. For short distance or short travel range operation, the PHEV can be operated just like the PEV. And for the longer range operation, then the PHEV can be operated like the HEV. So it combines the advantages of these two. These are some top-selling PHEVs between 28 and 2018. These are the models. Okay, the fourth category is fuel cell EV. Fuel cell EV is the type of electric vehicle which uses the fuel cell instead of the battery to power its onboard electric motor. So here the fuel cell actually functions as the generator. The fuel for the fuel cell is hydrogen, is compressed hydrogen stored on the EV. And to generate the electricity, it will use the oxygen from the air and the compressed hydrogen to generate the mechanical reaction in the fuel cell to generate electricity. So the emission from the fuel cell EV actually is just the water and the heat, because the mechanical reaction of oxygen and hydrogen will generate the water. The range of the FCEV depends on the amount of hydrogen carried by the vehicle. Typically, it's from 400 kilometers to 600 kilometers. These are the pictures of some FCEV, and this one is the structure of the FCEV. There are some issues related to the FCEV. First is how to get the hydrogen. This is the key point. According to the current industrial hydrogen generation method, the hydrogen generation actually consumes a lot of electricity, the power. The efficiency is not so high. So the fuel cell EV is a green car only when the hydrogen is generated by using renewable energy. Otherwise, it may not be considered as the zero emission car. Second is FCEV is more suitable for the heavy duty vehicles like trucks and buses. This is based on the current technology and hydrogen generation. Why it is like this? Because the time limitation, I cannot explain too much. And it needs a different infrastructure system from other EVs. So far, no publicly available hydrogen filling stations are available in Singapore. And it is not expected that the passenger fuel cell EV will be introduced to Singapore in the near future. Okay, next, I'm going to discuss some of the main components of an EV. Typically, there are four main components, not including the mechanical components. That is the powertrain system, battery pack, and the battery management system, or BMS, charging system, and the control system. Powertrain. The components of the powertrain of an ICE car include engine, transmission, drive shaft, differentials, emission control, exhaust, engine cooling system, and so on. It contains actually quite a number of components. But for EV, especially for pure EV, it is quite simple. The powertrain of pure EV has 60% fewer components compared with the ICE vehicles. But HEV and PHEV may have more components because they have two set of systems. Okay, these are the major components for the PEV powertrain. It includes the battery pack, electric motors, and single ratio transmission. Electric motor and a single ratio transmission, these two parts typically are built in one unit. And the motor in all the modern EVs is DC motor instead of AC motor. And the third part is the DC AC converter. It is also called the inverter. Okay, so for some EVs, this part also integrated into the motor and the transmission unit. So these three in some EVs are built in just one single unit. Okay, this picture shows the main components of the PEV powertrain, that is the battery pack, the inverter, motor, and the single ratio transmission. These two parts typically built in one unit. In some EVs, all these three parts built in one unit. Battery pack, shown here is the battery pack of the Tesla's Model S. The battery, they use the small batteries like this, and 444 small batteries used to make up of one module, and 60 battery modules are used to build the battery pack of the EV. You can see it is quite complicated. Only Tesla use this way. Other EV makers actually do not use this way. I'll give you another example. In this case, this is the newest battery pack from BYD, Han EV. They use their innovative bleed battery cells. These are the bleed battery cells, and this is the battery pack for the BYD's Han EV. Battery management system. This system continuously monitor the state of the battery and will take necessary measures in case of malfunction. It also performs the cell balancing. What is the cell balancing? We have no time to explain in details. It is to deliver maximum efficiency from the battery pack. And it also communicate with other electronic control units and sensors. When the battery is charged, when the EV is charged from the EV supply equipment, then the BMS will control the charging input, check the current state of charge or SOC, and share the data about the battery specifications with the EV SEs. Charging system. All the EV has the onboard charger. This onboard charger to charge the EV from the low power AC power supply. And when the EV is charged by using the external high power like the DC charging equipment, then the BMS will communicate with the EV SE to share the battery information and control the charging process. So this one is for the high power and fast charging. EV control system. EV control system is very complicated. It consists of several electronic control units, also called the ECU, which are basically software programs actually integrated with the different EV systems to help data exchange and processing and control. These are some examples of the ECUs, like the powertrain ECU and the BMS and the body control module, or the BCM. In some advanced EVs also has the autopilot system to function for the autonomous driving. The communication between the different ECUs actually is using the controller area network. Okay, these are the major components in the electric vehicle. Next, let us discuss the charging standards. Now, in the world, there are mainly 5 charging standards. The first one is called the SPxSGBC. This charging standards mainly used by US and Europe. It has 3 types. In this standard, they actually divide the charging system into 3 types: AC level 1, AC level 2, or the DC charging. And the second one is the CCS, or combined charging system, or combo charging system. This one actually is the DC charging standards for the SAE J1772. Also 2 types. In US, they use the CCS1, and in Europe, they use the CCS2. And CHAdeMO is the Japanese charging standard, and GB20234 is the Chinese standard. Tesla do not use any of these charging standards. They have their own supercharger and their own charging standards. Singapore, our charging standard is called the TR25. It is last updated in 2016. It is based on the SAE J1772 for the AC charging and the CCS2 for the DC charging. Shown in this figure is the connector and vehicle inlet for the different charging system. They are DC fast charging connectors. Okay, shown in this figure is the conductive charging modes. There are 4 charging modes for conductive charging mode, and one, the wireless charging mode. This one is not available commercially. We do not discuss this one. The first one is directly connect the charging cable to AC power outlet. This charging mode is forbidden in Singapore, not allowed. The second one is same as the mode 1, but the difference is the charging cable. For this charging cable, you may notice here has the component. This one is called the in-cable control box. So if the this cable can be obtained from the EV maker or supplier. If you use this cable to charge the EV at home, it is allowed. But this is for the low power AC charging. The mode 3, this one, use a wall box or charging station, AC charging station. It is typically fixed on the wall or in a post, on a post. This charging station will provide the cable for the charging of EV, and typically use the AC charge, can be a high power AC charge. The mode 4 is the DC charging. This one is for the high power charging system, typically in the charging station, not at the car park or at home. These 3 mode 2 to mode 4 are allowed in Singapore. Okay, then how will EVs impact existing and new buildings? If you know the charging mode allowed in Singapore, then you will be able to understand the points discussed here. First, slow AC charging will likely be the most common way of charging. The slow or low power AC charging can take place at residential car park for the overnight charging, or at the office car park for the charging when we are working. The fast charging point will be installed at suitable locations. Not all the locations are suitable for the fast charging, especially the high power DC charging. So these suitable locations may located in these locations like the petrol station, shopping mall, and so on. These charging stations will require to upgrade the existing grid infrastructure because they require quite high power. And LTA will monitor the EV adoption and consider making it mandatory for new developments to cater sufficient electrical capacity to support the EV charging in their car park. This may include the upcoming HDB towns, commercial buildings, and the new private residences. LTA actually are striving to install EV charging points at every existing HDB car park by 2030s. The first 8 HDB towns are the Ang Mo Kio, Badok, Choa Chu Kang, and so on. These 8 HDB towns will become EV-ready towns by 2025. Okay, last, let us discuss the challenges faced by EV. We will discuss these 4 issues: the construction of charging infrastructure, cost of battery, range limit of the battery, and the long charging time of the battery. And last but not least, safety and reliability. First, construction of the charging infrastructure. It is estimated by 2027, the worldwide EV charging market will reach 38.9 billion. This is a quite large market, but at the starting stage, it may not be able to attract private investment because at the starting stage, build the charging point or charging station may not make money. So this will require government incentives, subsidies, and funding to drive the growth of the electric vehicle charging station market. And then actually now the infrastructure of the charging system is the bottleneck for the adoption, for the fast adoption of EVs. If you see the 2 different markets, US and China, their charging infrastructure, you will know why China now is the largest EV market in the world. So this figure shows you the charging stations in the different states of US. The California has the maximum number of charging stations, totally about the 22,620. This is the data by 2019. Now you look at the China's. This is the top 10 provinces or cities in China with the most public charging units. This is the data by 2020. The first one is Beijing. They have 87,634. Guangdong and Shanghai, you can see they also has more than 85,000. Even the number 10, Hebei province, they have 31,000 800 public charging stations or charging units. Even the number 10 has the larger number than California. So that is why China actually has the largest EV market. Their infrastructure support the fast expanding of the EV market. Then what is the current situation in Singapore? By the end of 2020, we have 1,800 public EV supply equipments all over the island. And we have only about 1,900 registered plug-in EVs out of the total 940,000 registered vehicles. This is only about 0.2% of the share market of EV. So this is our current situation. So our target, to achieve our target, it is actually a tough task. Okay, second is the cost of the battery. In the last 10 years, the cost of the battery actually sharply reduced from the more than 1,000 US dollar per kilowatt, dropped to below 200 US dollar per kilowatt. But battery pack is the most expensive component of EV. Although the prices has sharply dropped, but it is still has the big gap with the target cost. Our target cost is about $100 per kilowatt hour. If the battery price can drop to this level, then roughly the ICE car, the EV, the price can compete with the ICE cars. So now we still has the certain gap to the target. Another pinpoint of the EV is the limited range and long charging time. The limited range because now the EV only has limited capacity. The room to accommodate the battery. So we cannot increase the battery, the size of the battery pack to increase the range. Only can increase the energy density of the battery to increase the range. But increase the energy density according to the current technology, the high energy density battery actually has the less thermal stability and the lower safety. This is the contradict to our safety target. And also the fast charging reduce the life cycle of the battery. So how to increase the range and also increase the reduce the charging time is still a hard task for the battery improvement. Last but not least is the safety and reliability. Because the current technology of the battery, the safety issues quite often come to the public notice in the news. Typically, the issue caused by the mechanical bills, electrical bills, and the thermal bills, and all the three bills eventually result the thermal runaway, then cause the fire. About the details, I think I have no time to explain in detail here. Then can we solve the problem? The hope is there. Actually, just now I mentioned the bleed battery innovated by BYD. This is the China's automaker, EV maker. They come out the bleed battery. This bleed battery use the LFP, lithium iron phosphate battery. So actually, they solve the problem in large extent, but because LFP battery in low temperature, their capacity will sharply drop. So it is still ideal for the EV battery. In Singapore, we do not have this problem, but in northern part of the Earth, of our planet, in the winter days, the temperature may be quite low. So this will be a problem. Fortunately, we have another hope, that is solid state battery, lithium battery. This one is the new type lithium battery. It uses the solid electrolyte instead of the liquid electrolyte. If this battery is successfully used for EV, then it will be able to largely improve the safety of the EV, and also can increase the energy density, so extend the range, and also it is suitable for the fast charging. So actually it can solve the 3 pinpoints of the battery. So far, this one is the hope to solve the battery problem. Okay, that's my presentation.
Our next speaker is Ms. Olivia Wu, Director, Mobility Sustainable Energy Solutions from SP Group. In the current role, Olivia leads a dynamic team responsible for building and managing SP Group's mobility business, which is focused on developing a nationwide electric vehicle charging network across Singapore. In the presentation, Olivia will provide an overview of the EV charging infrastructure landscape in Singapore, implementing challenges, and how charging operators like SP are helping to accelerate the adoption of EVs. Now over to you, Olivia. Please share your webcam, unmute your audio, and share your screen before proceeding.
Hi, good afternoon, everyone. My name is Olivia, and as Joel has kindly introduced, I'm from SP Group, and I lead the mobility team within the company. Many of you will be familiar with SP. We are the grid operator in Singapore. We operate transmission and distribution for electricity and gas. And we also are, as many of you will know, we provide the bills to many of your households. So a couple of years back, SP actually decided that we would explore additional areas to drive revenue for the group. So while our traditional and core businesses remain in grid, in gas, and in SP services, we also have a couple of us in a small team in sustainable energy solutions that are looking at new areas which we feel could be growth areas for the company. So my colleagues look at areas like microgrids, solar, district cooling, and my team specifically focuses on mobility and EV charging for our main core of work today. So, I think Dr. Wang has given you guys a really good overview of where things are at in terms of the state of the industry right now, right? So the EV revolution undoubtedly is here. If you look at some of the charts, similar to the ones that Dr. Wang has put up, actually the growth in EV adoption has accelerated very significantly over the last couple of years. China obviously has been a big driving force for this, but at the same time, you also see Europe playing a big role in terms of driving the EV adoption. They have had the largest growth in terms of annual increases year on year. So then if we take a step back and take a look at what these trends are telling us, it means that EVs are already on the way here. Many people around the world in many different countries are already adopting these technologies. And what does that mean for Singapore? Right? So where my team started is that we started our journey in the middle of 2018. And I thought that I would maybe use our journey to share with you some of the considerations, some of the concerns, and some of the obstacles that we faced in trying to build out our EV charging network in Singapore. And that also then allows us to have a little bit of food for thought in terms of how we might be able to progress moving forward, right? We launched our network in January 2019. And back then we had a humble 38 charging points at 8 locations island-wide. So, started very small. At that time, there was no particular government policy. There were no targets set at the time. There were only a handful of EV models that are available in the Singapore market. But at the same time, we felt that it was something that was important and was something that was the future. So we did our part and we actually committed to building an EV charging network across Singapore, regardless of the rest of the environment at that particular moment in time. We are, of course, also encouraged by all the adoption as well as all the trends that we were seeing globally. And we were convinced that actually that was something that would eventually, before long, come to Singapore. So what we did was that we drew on our experience operating our own EV fleet. We started this quite early in 2016 or so. And what we did was that we bought a fleet of EVs and we actually allowed, we asked our power grid colleagues to use them in their daily operations as they went about the substations, went about their daily maintenance and operations work around Singapore. To date, we have 44 EVs in the fleet, and we are actually expecting to almost double that over the next couple of months. So we will continue to grow our fleet, and we're very committed to doing this for our own vehicles as well. And this process actually allowed us to gain a deeper understanding of some of the technical considerations, potential user considerations. So we had workshops and roadshows with the potential drivers, and they asked us so many questions about range, about charging, how they would fit this into their daily operations and some of their daily routines. So we went through that process ourselves, and we learned a lot through that exercise. So through that, we actually were able to identify and recognize the key considerations for potential EV adopters. Interestingly enough, I don't think these concerns have changed too much from then until now. A major consideration number one will be whether they are affordable and suitable EV models. In terms of some of our fleets, for example, we were concerned about payload, whether there was a sufficiently large space for us to carry out equipment. And of course, range was a concern. The other part of it was obviously whether or not there was EV charging infrastructure that was available, whether it's pervasive enough, whether it's something that you will be able to access regardless of which corner of Singapore you happen to be in. At the same time, with charging infrastructure, there's always been sort of this chicken and egg conundrum, and you might have heard this phrase being used in many of these discussions about EVs. And really, it's about when a vehicle owner or a fleet owner thinks about whether they want to convert to EVs, the first question they'll ask is, well, are there EV chargers? Is there EV infrastructure that's available for my use? But at the same time, for an operator, a charging operator, to actually put in EV infrastructure or EV chargers on the ground, they would also be asking, well, is there any vehicles that will be actually using my chargers? So it becomes a bit of a cycle where everybody's waiting for everyone else. So what we decided to do was actually to try to crack that and to push the adoption a little bit, help to accelerate that process by building infrastructure ahead of time. So we set out to own and operate a pervasive EV charging network all across Singapore. We knew that there were a couple of things that we needed to bear in mind. One of them was really convenience to users and reducing range anxiety. It's quite interesting because Singapore is really not a very big place, right? If you talk to people from Europe or from the US, I've heard this comment many, many times, which is that Singapore is really the perfect place for EVs because we're so small, it's so contained, you really don't have a problem with range at all. The average driving distance in Singapore is 50 km per day, right? And if you look at some of the numbers that Dr. Wang had put up earlier, you see that for most typical EVs that are available in the market today, the range actually far exceeds 50 km. So you wouldn't have a problem. You wouldn't get stuck or stranded, right? But still, it's a mindset. It's a concern as a new EV user. It's very natural to worry about that. We also thought about having a very strong technology focus. So we knew that EV charging and EVs in general is really a very quickly evolving field. So we had to make sure that we were up to date with the technology, understand what the state of the art was at that point in time, and also to continue doing ongoing research and piloting to make sure that we keep up with the latest developments in the industry. Digital is a big focus for us. So we wanted to make sure that user experience is very seamless and very user-friendly. So we have an app, many of you might have used it, it's called the SP Utilities app. So we wanted to make sure that the EV charging module was also integrated in that same app so that you can find a charging station, you can navigate to it, you can authenticate, you can build, you can do everything on that same app. Wanted to make sure that customer support is very good, reliable, efficient. And last but not least, really trying to tap on the power engineering expertise that we have within the company to ensure that we have very efficient mechanical and electrical design, as well as to make sure that we have a 100% safety track record. So then with all those considerations, we set out to build an ecosystem, because those considerations were somewhat internal, things that we had to make sure that we put in place and ensure that they're working fine, right? But beyond ourselves, we also needed a whole group of companies, whole group of partners to come along with us on this journey in order for this to be successful. So you'll see here that the charge point operator, somebody like SP, will be right in the middle here. And there's actually two parts that you have to deal with. The first on the left is actually the building supply. So there are many buildings in Singapore today, right? You go to lots of places, many car parks, people will park their vehicles there as a matter of the regular day-to-day. But we actually had to go and convince many different landlords, many different premise owners that EVs were a good idea, that EVs that were the future, and they were actually coming, so that we are able to then place our EV chargers in these locations. SP is not a company that actually owns a lot of real estate, so we're not a landlord or a developer. So we actually rely on a great ecosystem of partners in order for us to build the supply for locations for our EV chargers. The other piece of it, actually, equally or arguably more important, is really generating demand, right? Because I think the challenge here is if you build a whole lot of EV chargers, you put them all over, you invest a huge amount of capex into the ground. If there's nobody going to be using your chargers, then you have a new problem as well. So we also engage, with many different fleet operators, as well as thought about how we can potentially service the end consumer. So I'll talk a little bit about both of these and how we overcame some of these challenges, starting with the supply. So we really said, okay, we need homes, we need locations to place our chargers. And how do you think about this, right? Depending on the characteristics of the location, the use case actually changes quite significantly. And the type of equipment that you need to put in that location will also change. So what do I mean, right? If you look at a residential location, typically what you would expect is someone goes there, charges overnight, wakes up the next morning and picks up their vehicle, goes off to work or to wherever it is that they're going, right? So in a case like this, you actually don't need very fast chargers. Regular or slow chargers are just fine. They would actually meet your needs. In a workplace, very similar, right? You have people, now we are in COVID, so I guess that's changed quite a bit, but in regular times, you would actually have people spending a significant amount of time at the workplace. So, 8 hours, 9 hours, that's perfectly normal. So to have a regular or slow charger at the workplace also works quite well for office staff and for tenants. The last part of it is really, the third category is really this in the interesting category where we have a whole bunch of different types of buildings, whether it's industrial, commercial, or even retail, tourism, and hospitality locations. And here you start to have different categories of users that will come into the premise or come into the car park. One category will be very similar to the previous cases, staff and tenants, so people that spend a significant amount of time at that location. But you also have visitors and other transient users that are in there in a location for a shorter amount of time, maybe 1-2 hours. They could be there for shopping, grocery shopping. They could be there for a meeting. They could be there just to run a couple of errands. So in those cases, you actually need a fast charger because that allows these transient users to be well served because they're not going to be spending a huge amount of time at that particular location. And what's interesting and what I wanted to point out is that in Singapore's case, we are actually of the view that this is a viable alternative to residential charging. So if you think about places like Europe or in the US, many people actually have access to their own garage, their location to park their car. And it's right next to their house, and many people live in landed properties and things like that in those countries. But in Singapore, most of us live in high-rise, and a large percentage of those high-rise buildings are HDBs, right? And many people would have observed by now that actually there's not too many of these EV chargers in HDB locations or even condominiums. And we are very happy to see that the government is starting to take steps. They're putting out tenders, they're allowing operators to go and enter into these car parks to provide these chargers for residential use, but it will take some time. There are also power considerations, power constraints in some of these car parks, where actually they weren't really quite built for EV charging to begin with. Perhaps the car park might support lifts, it might support lights, but there's not too much available power above and beyond that. So in those cases, then it may take some time for the residential locations to actually have a significant number of chargers that are available for overnight charging for people who live there. So we believe that actually in building a fast charging network that is actually spread across all of Singapore, that helps to plug the gap to actually allow people to charge their vehicles at locations like malls, at locations like industrial buildings, or anywhere where they might be going about their day-to-day with a fast charger. So they don't have to spend too much time there. They can match it with whatever activity they're doing at that point in time. And it can be a viable alternative to residential charging. And the last category is really dedicated use locations, such as petrol kiosks, right? So we would know that a number of the petrol kiosks have already rolled out EV chargers at those locations, and typically those are fast chargers. The benefit of doing this is actually that it fits in with established behavioral patterns of vehicle users. So we're all used to driving into a petrol kiosk to top up your tank, so as to speak. So that's actually something that's, I think, quite comforting, right, for new EV users. But at the same time, with petrol kiosks, there tends to be a limited number of activities that you can do at that location. So in those cases, it would be a trade-off, and potentially you might find a mall to be more attractive. So we've actually had a very strong partnership with landlords and premise owners. When we first started, we collaborated with forward-thinking landlords, people who are very who believed a lot in sustainability, right? So Ascenders Capital Land was a big supporter of us at that time. They still are, and they've actually allowed us to install chargers at many of their locations. And in turn, we provided value to the properties by enabling convenient charging for their tenants. We also then enhance the value of their property, and to some extent bringing some footfall into the commercial malls, because people would go, and that's one additional reason that why people would actually go to a location, besides for their shopping, besides for running their errands, also to then charge their vehicle. And obviously there are a couple of points that you can get for a BCA Green Mark certification when you have EV chargers in the property. So then we started thinking about how we operationalize a network, right? So you find the home for the chargers, what's next? And we thought about a couple of different aspects. One of it was really software. And some of you may know there's actually a very strong in-house software capability within SP Group today that has allowed us to build our SP Utilities app. It's also allowed us to build a backend that will allow us as the operating team to actually have sight of all of our chargers around Singapore. The status, whether it's somebody is using it, whether there's actually a fault. So any of these things, the status of the charger is actually something that we can see very clearly on this dashboard, and we built all of this in-house. So that allows us to have full control over our systems. It also allows us over time to build in additional functionalities and actually also upgrade the technology. There's also additional opportunities for us to use data to provide insights for our partners. So sometimes we get landlords or premise owners asking us, hey guys, can you tell us how our chargers are performing as compared to the other chargers on average in your network? We can provide that data. We also can over time gain network efficiency. So when we plan our network, when we pick the next location or that next landlord for us to call on, we can then figure out which locations are very popular and where there is a greatest need for more EV charging. On the hardware side, we also have very strong power engineering expertise. I've mentioned that. We also have a very close partnership with our LEWs. And as many of you may know, if you're from the building space, every building has their own building LEW that's in charge of the building. So we work very closely with them to make sure that we engage with them at the same level. We explain to them what this new technology is about, and we get their comfort and assurance to support us on this journey. Our team also has done rigorous testing to ensure that the chargers work as expected, including safety, including security, such that when we actually introduce a new piece of hardware into our network, we know that it's going to work just fine. The last bit to mention is that there's actually a TR25, Technical Reference 25 framework in Singapore. This allows everyone to ensure that safety is adhered to. So what this means is that whenever a new piece of hardware wants to be used in Singapore in a public location, you have to make sure that you get TR25 certification. This is great because it gives us and gives our partners a lot of assurance and a lot of confidence. But the drawback would be that it does increase to some extent the barrier to entry for new equipment to be introduced into Singapore because there is a fairly lengthy and sometimes costly certification process for the TR25 to be obtained. So I've talked a bit about the building supply, right? So on the left, and obviously I think the other part of it was actually generating demand. And one of the first partners that we had was really Grab, and they came along with us at the beginning of our journey, and they committed to actually growing their fleet of electric vehicles to 200. And that really also gave us the confidence to actually expand our network and to go out and build, because we knew that there would actually be a supporter in Grab to actually help us do this. And there are actually many other fleets that have come on board since then. But we have sort of these original partners that came along with us at the beginning of the journey. So then now fast forward 3 years, where are we today, right? The government direction is very clear. EVs are here and they're here to stay, right? Dr. Wang has talked a little bit about this, and I've listed them out here just for everybody's reference. And just to do a quick summary, in essence, there's actually been many different aspects that have been announced in the last couple of budgets. There are infrastructural targets, 60,000 charging points, 8 EV-ready towns. Every HEV town will be EV-ready by 2030. There are also vehicular incentives for EVs themselves. So if you buy a passenger vehicle today, there's you could get up to 45% rebate on ARF up to 20,000, as well as 25,000 for under the vehicular emission scheme. So that's actually 45,000 in total, right? And many other similar rebates for commercial vehicles, vans, as well. There were changes to road tax to make them on par with ICE, so that's very helpful. As well as additional grants and incentives that have been set aside for EV-related initiatives. So this has been great. I think it's wonderful to see the government coming along and throwing their support behind the EV revolution. But if I have any government colleagues out there, it's not enough. We'd like to see more, because the switch to an EV is not just changing the vehicle. It's a change of mindset. It's a change of perspective, and it's also a change of many operational details that perhaps only the fleet owner would be familiar with and would have to deal with. So, you need to plan your route, for example, to think about how you want to charge the vehicle at the end of the day. You need to make sure that, your routes are not too long so that you don't exceed or you don't get too close to the edge of the range for the vehicle and things like that. So, we'll be really happy to see even more incentives and even more support from the government. I think that, we can use all the support that we can get. On the OEM front, I'm sure Jasmine will talk more about this later, but many EV models are now available, right? And there's even more to come. So the chart on the left is from our friends at Deloitte, right? So they've actually scanned the space, and there's many announcements from all the auto OEMs in terms of what they are planning to do for EVs. Lots of investment going into technology, lots of targets in terms of the percentage or the number of vehicles that are electric that they're going to sell. In Singapore today, up from a handful just 3 years ago, there's 19 different models, as well as 4 vans and light goods vehicles that are available. It's not a big number right now, but I'm very confident that even more are going to be coming. And many of you might have read the news, but even going to be manufacturing EVs in Singapore. And Hyundai Group is actually committed to putting their smart factory in Jurong, and they're building it right now. So I think that's also going to be a huge boost, and it's going to give a lot of people a lot of confidence to say, hey, I'd like to drive an EV that's been manufactured in Singapore. So very exciting times for the industry as well. So through this entire journey, we've really been able to grow our network to expand, right? From a humble 38 points, we have 340 charging points across Singapore. That was at the end of March. My colleagues have been actually on the ground building as we speak. So that number has already gone up over the last couple of months. And of which actually almost a third are actually DC fast charging points. So giving assurance, giving optionality to different users who may or may not have a residential charging point at their homes today. And we are in 71 different locations. We have a strong ecosystem of partners. So these are all the landlords that have come along with us. And we are in all different types of buildings, whether it's industrial, commercial, malls, even some country clubs. And we're also building in some of the Caltex petrol kiosks as we speak. And like I mentioned, the number of fleets that have come along with us has also increased significantly. So most recently, we announced a partnership with SMRT, and they're going to be actually having their taxis charged on our network. We've evolved our business models to the different needs of different customer segments. So we partner with auto OEMs, we partner with condos to make sure that all the different needs of the individual EV owner are met. And we also work with fleet operators and corporate fleets to actually provide customized installations at depots, warehouses, and other comfort locations. And all in all, across both of those segments, we continue to grow our public EV charging network to ensure availability and accessibility of charging all across Singapore. We continue to be committed to technology development. So we will work on smart charging, which is actually trying to expand the power capacity on site to support a larger number of vehicles, as well as fleet solutions. So helping fleet owners that are just starting to manage and convert their fleets, to manage their fleet a little bit better, integrate the needs for charging, and to make sure that their operational needs are not compromised. So all in all, in summary, SP and me personally, we're very optimistic about EVs and the future of EVs in Singapore. Many of the key pieces are already falling in place. Technology is there. The battery technology has significantly improved. Charging standards have matured. Government done a lot of work in the last couple of years. Very, very excited and happy that my colleagues in government have done all these things as part of the Green Plan, with all the targets as well as commitment to phase out internal combustion engines, as well as narrowing the cost gap through different structures for taxes and rebates and so on. The economics already make sense for high mileage vehicles today, and we expect that EVs will reach upfront price parity with ICEs by the mid-2020s. And last but not least, actually companies, my colleagues in the auto OEMs, the fleet owners, everybody is doing their part to bring in more EV models into Singapore to electrify their own fleets, accelerate that process, as well as people like us, charge point operators who are actively growing the EV charging networks in Singapore. So in conclusion, if you have a fleet, if you're a fleet owner, you're thinking about electrifying, not quite sure how to go about it, you have a couple of questions, or if you're a landlord or a premise owner, you're keen to install EV chargers on your site, I think we're more than happy to share our experience. It's been a good 3 years, very exciting, very dynamic space, and I think we look forward to the future, and we're more than happy to share that with more parties who are also keen to come along on this journey. Thank you very much. My name is Olivia, and it's been a pleasure talking to you guys today.
Thank you, Olivia, for that very detailed, comprehensive presentation on EV charging infrastructure, SG Green Plan, a number of topics that you mentioned to support our nation's green mobility ambitions. Now, our third speaker is Ms. Jasmine Wong, Chief Executive Officer and Managing Director of Inchcape, Greater China and Singapore. As an automobile brand, Inchcape plays a part to support the government to reduce CO2 emissions. In this presentation, Jasmine will be sharing Inchcape's strategic plan in terms of case planning and product portfolio to match with the SG Green Plan. She will also talk about what electrification is and what we can do as infrastructure matures in Singapore. Now over to you, Jasmine. Please share your webcam, unmute your audio, and share your screen before proceeding.
Hi, thanks, Joel. I hope you guys can hear me. Okay, my name is Jasmine. I'm looking after the Inchcape business in Singapore and Greater China. So for the greater people who knows about Inchcape is a global automotive distribution company. And in Singapore, we are popularly known as the Bonio Motor as well as the Champion Motors. So we are the strong market leader because we are selling not just the Toyota Lexus fleet, we also have the Suzuki Hino, and we are participating not just in the public arena and we are also in the commercial vehicles as well. So being a strong player in this auto transportation line, it is very important that we play a very active role to make sure that the whole organization is in line with the green movement set up by the Singapore Green Plan. So let me share the. Hello, can you hear me? Okay. Right, so coming to the first slide that I have, okay, just put a little bit of perspective, which I'd like to share a bit, is that the whole ideas of Singapore is to actually overall reduce the carbon emission profile. And if you look at this profile, while transportation might contribute a total carbon emission of 13%, it's not the most significant compared to the other industry activities as well as for commercial and personal consumption. But having said that, transport is a very emotional part of the life of Singaporean, and the fact that we contribute 13% of the total carbon emission in Singapore and is very highly visible. It is important that everyone participate and take steps to try to reduce our carbon emission footprint. So as part of the Singapore Green Plan aim is to position us to overachieve our long-term net zero emission aspiration as soon as viable. Under the UN 2030 Sustainable Development Agenda and Paris Agreement, Singapore will enhance its 2030 NDC to peak emission at 65 million tonnes of carbon dioxide emission around 2030, which state that Singapore aims to achieve a 36% reduction in emission intensity from 2005 level by 2030. This is an ambitious project, and I think everyone have to work together towards this common goal, irregardless of which industry we are in right now at the moment. So the Green Plan aims to do a few things. One is first, we need to accelerate our infrastructure plan of putting charging stations to make sure that EV become a way of life. And also, the more people own the EV, it become more economical to actually have EV supply in Singapore as well. So there are multiple EV incentives and lower road taxes for EVs that help to promote. And that all drive towards a cleaner vehicles by 2040 as the final goal of the Singapore Green Plan 2030. So just a little bit of perspective. Toyota also have this environmental challenge of 2050, takes the measure with the aim of achieving zero carbon dioxide emission and a net positive environmental impact, and will continue to contribute to the realization of a sustainable society. By 2030, the Toyota estimate 35% or more reduction on the global average CO2 emission. So this plan is very much in line with the Singapore Green Plan. In fact, I would say that it's even more ambitious. So in order to achieve that plan of carbon dioxide reductions, what happened is that they go through a series of making sure that they introduce a whole slew of electrified vehicles that include hybrid vehicles, PHEV, FCV, and EV as what. And this whole range of vehicles is supposed to have a cleaner, better emission in terms of CO2. So what is the plan that Inchcape, which is Golden Motor Electrification Roadmap, is like? So the first immediate step for us right now as part of the Green Plan is that we need to expand and increase our hybrid sales lineup, which is a very HEV point of view. And we need to increase the adoption rate for hybrid. Hybrid and EV is about changing the lifestyle of our consumer. So we need to continue to increase the adoption and education process. And also we are starting our EV journey with the launches of, we started with our Lexus EV that we come in, and we're going to have more EV model that's coming out moving forward. And we are also participating, planning with strategic partners to support a smart city urban planning. So this is what we are doing immediately at the moment. The mid-term plan is that hybrid will be the main selling variant for all our models. And we will aggressively roll out the EV and PHEV models as our infrastructure matured accordingly. And by then, we will also have key models from the smart city concept to show the way forward for automotive industries. And the longer term plan is that every model should have an electrified variant to support the mass adoption, while hybrid continue to be the core models together with the EV. And we are also going to engage with the government to support autonomous driving, as this is it's part of sharing economies that's moving forward. So what is our plan? First, we are already actively involved in telemetric with Grab. And what does telemetric do is that it allows us to get connected, it allows us to have real-time information with the after-sales team to understand the prevention, maintenance, and servicing of our car. And this allows less breakdown period and also making sure that our vehicles continue to be greener. And the second thing is that we're also aligning with the government initiative for Smart Nation through autonomous. We've done some pilot testing on Easy Mile and Comfort Delgro, and first together with NUS, and we are going to do more of such testing to make sure that we are in line with the autonomous roadmap. And not only that, we just started to roll out this Kinto Share program. This Kinto Share program is is almost like allowing people to have a first-hand trial on how does it like to have an EV as well as hybrid car, and that will allow a more it's more like an adoption and education process for our customer, so that to get them to be more comfortable on the electrification journey. And not to forget, we need to launch exciting models. Other than all the hybrid that we have, the EV will be the upcoming news that will launch more aggressively over this year and next year periods of time. And having said that, the whole EV launches is a lot of learning experience for all of us. In fact, when we launched the UX EV this year, we were very happy and positive that there is a lot of positive supporters, and we have a lot of leads who show excitement. But there is still a lot of lifestyle changing that need to be, because some of the questions that all these customers come back to us is that, can I drive to Malaysia? This is because of infrastructure. The second question they ask is that, what is the resale value of the EV car? Because Singaporean has the habit of changing car every 4 or 5 years. So what does that mean if I buy the EV? Correct? How long can a battery life last? Correct? And then charging infrastructure. So there is a lot of questions that customers are always asking whenever we try to launch an EV, or we try to get some conversation that's going on. And eventually, what I'm happy about is that, while not all of them buy the EV, but a lot of them actually decided that they'll go for hybrid, because it's much more suitable for their lifestyle, and they felt that they're going for a cleaner emission, and it's their first foray into electrification before they take a bolder step, or when everything is more ready for them to take on an EV. So this is some of the journey that we are embarking on to help to motivate the Singapore population into electrification journey, and also getting them more comfortable with the idea of electrified vehicles. So, as what we mentioned, we launched our first EV that's happening, and we are also ramping up. Our hybrid sales are moving very aggressively. In fact, we used to have this Toyota SUV Harrier, which is our flagship, and we have recently switched our turbo engine to electrified hybrid powertrain, offering the same level of performances, but with a 40% lower carbon footprint and a quieter ride. And not only that, Toyota has always been the first brand to offer hybrid vehicles to taxi operators, and we will continue to engage the fleet as well as the taxi operator to go green, go hybrid, and also whichever possible model that's coming in to help to reduce the emission level. And we intend to expand every portfolio to have more hybrid options by 2024, so that all customers have a choice to run on a cleaner energy. So the team is aiming to introduce all electric models to the market together with the government effort on the charging infrastructure. So just a little bit of information that we should also look at the efficiency of the CO2 tailgate emission reduction, given the efficient allocation of precious and finite resources. To produce batteries used in hybrid and EV, precious metals are needed: lithium, cobalt, manganese, and nickel. From a carbon reduction from a vehicle tailpipe POV, a typical hybrid will help to achieve a minimum 35% reduction in carbon tailpipe emission, while an EV will achieve 100% reduction with no tailpipe emission. So EV is 3 times more efficient in reducing the tailpipe emission. From a resource point of view, a typical hybrid requires 1.3 kilowatts of lithium-ion battery, whereas a typical EV requires 60.0 kilowatt of lithium-ion batteries. So hybrid consumes 60 times less precious metals than the EV. Than the EV, right? So the overall objective of electrification is towards the overall goal of carbon footprint reduced to fight global warming. When electrification consists of hybrid plug-in and EV, it is more efficient to focus on a single source EV to cut carbon emission. I mean, just to give a bit of perspective, in Singapore, total cars plus taxi is 650,000, out of which hybrid occupy 51,500. And electric car at this moment is only 1,200. It takes up 0.2% of car population are EV and about 8% are hybrid. So there is much more immediate substantive impact of carbon reduction in mass electrification, hybridization, and EV rather than just focusing on one sort of EV. until the charging infrastructure and battery costs reach the optimal level by 2030. Therefore, multi-pronged electrification, there is more efficient allocation of precious resources and opportunity for many more consumers to make a small but significant difference than limiting to a smaller population to reduce the carbon emission. So with that, I end my presentation, and the vision is to bring mobility to the world community for today, tomorrow, and for the better. Thank you.
Thank you, Jasmine, for going through with us what EV adoption means to the private and commercial owner, as well as to building and car park owners. Now, last but not least, we have Mr. Tam Kwang Sheng, Chief Technical Officer of Scorpio Electric Singapore. Mr. Tam has a wealth of experience ranging from his time as a development engineer at Apple to entrepreneurial ventures centered around battery technologies and artificial intelligence to most recently leading the Singapore government autonomous vehicle program. His presentation will cover an overview of the two-wheel EV landscape in Singapore, outline key EV technology and development trends. Over to you, Mr. Tam. Please share your webcam, unmute your audio, and share your screen before proceeding.
Thank you, Joel, for the kind introduction. Hello, everyone. My name is Kwang Shen, and it's a pleasure to be here today with all of you. So let me start by showing a very short clip. I hope this works. Okay, so I work for a brand named Scorpio Electric. We are an electric vehicle company based in Singapore, specializing in designing and manufacturing high performance premium electric motorcycle. So I'm responsible for the technology and R&D in electric powertrain, electronics, the software, and connected vehicle. Now, there are three pillars that guide what we do. As you can see from the short clip just now, we pay a lot of attention on the importance of having great design matched with best-in-class performance and enabled by technology. And today, I would like to share the current state of the EV development with respect to these two pillars about performance and technology that will generate useful conversation amongst many building and sustainability practitioners here in the audience on impact on the infrastructure. Now, you may ask why electric vehicle or why electric motorcycles? So by now, I'm sure everyone here would have heard narratives, one form or another, on the benefits of EV, as well as challenges surrounding its deployment. But we see several motivations that is in line with our core pillars. First, from the consumer angle, the reason for choosing electric vehicles have to be the reasons of supporting a sustainable future. Second, it is imperative that electric vehicles address the mobility challenges facing urban cities, namely congestion, first mile, last mile connectivity gaps. And we believe the advancement of micromobility, in this case, motorcycles, can help to address those gaps. And lastly, we want to enable a lifestyle choice, whereby choosing an electric motorcycle shouldn't be about just making compromises on a day-to-day basis, but of one that can better meet and even enhance our users' lifestyle. And this is becoming more evident as you can see the EV market today, and I'm speaking specifically here in this slide on the two-wheeler market. But the trend line would be similar to a four-wheeler segment. as well. Although the current EV market penetration is relatively low as of today, except China, of course. China is a different story. The total addressable market here, highlighted in red bars, where it shows the internal combustion engine numbers, is rather significant. And this upward trend of shifting to EVs will continue to grow as more and more government intervention, as well as what we are seeing today, will help accelerate this adoption. So as an EV designer and manufacturer, there is an array of factors that we have to consider in order to have the right product to enter the market. So besides volume and addressable market here, the following question is whether there are enabling infrastructure to support the adoption. For example, whether there are standards in the country to harmonize different EV charging, and also incentives for EV adoption, not just on the vehicle itself, but to build, operate the charging infrastructure. And it gets more difficult to coordinate and unify, especially in big countries. So these will drive the design of the respective systems in the EV development. And I would like to very, very briefly delve into three main areas without going into too much of the technical details. Now, first, of course, the battery, which forms one of the most critical parts of the electric propulsion system. So when we talk about performance here, it's not just about adding more capacity, more power, and more features. It's about balancing these two design considerations that I like to call it. How can we maximize range, and how can we have high charging availability? So range here depends on many factors. And one of the most important factors is the battery cell technology. And we can see the improvement in the capacity or energy density per battery cell at 30 to almost 50% year-on-year improvement. And there are different types of cells, like high power cells that can be optimized for faster charging versus high density cells that are optimized for range. Now, the evolution is the much talked about solid state battery that promotes or promises faster charging in a matter of minutes without degradation in the cycle life, and also shifting away from costlier materials like cobalt. However, this is still very much in the infancy stage, and it takes like 5 years to even a decade in order to materialize. And if that materializes, I think it will be a game changer for the EV space. Now, this leads to a very interesting two schools of thoughts here, which is worth noting, especially in the electric two-wheeler space. Having a battery pack solution that is stationary, that means it's fixed to the vehicle itself, or a removable, like a swappable, which is very popular in lower performance electric motorcycle that we see today. Now, each has its pros and cons and have impact on the charging infrastructure. So for removal battery packs, the advantage is, of course, having a faster turnaround, and that is very ideal for fleet operation. But the downside is you need a specific battery swapping infrastructure, and it becomes very difficult to standardize across different OEMs. Now, there are firms now forming alliances to define a standard for swappable battery packs, like Honda, KTM, Piaggio, and Yamaha has recently formed an electric battery consortium to actually define such a standard for motorcycle. Now, on the other end of the spectrum, if you have a stationary battery pack solution, like the one that we are designing here, you can see this picture here is the first prototype that we built. We have designed a range of up to 200 kilometers for a single charge, and this is good enough for a daily commute, especially in Singapore. And we are trying to align this with type 2 type of infrastructure, so that when these public charging infrastructures are made available, our users can actually tap on these charging infrastructure. So if you have a solution like this, then having a good network of public charging stations would be ideal, in addition to dedicated charging that you may have access at home or at your workplace. And this is the next point on why regulation to standardize public charging infrastructure becomes very important, especially in urban mixed-use environments. So for example, in Singapore, everyone knows or should know that we have a technical reference TR25 that is currently undergoing revision that detailed the technical compliance between EVs and the public charging stations. So with regards to safety, interoperability. And I think that supports city planners to scale the charging infrastructure in order to have an optimal vehicle to charging station ratio. The future, and I always look towards the future, and I believe it is the way to go, and especially for two-wheelers, is wireless charging, where you totally eliminate the need for a physical connection. And the SAE has recently released standard for wireless charging up to 11 kilowatt. And I think we'll begin to see more commercial route in time to come. Now, moving on to the other half of the electric propulsion system, which is the motor. And the main point I want to share here is that the motor, by and large, is seen as more of a commodity compared to the battery, which forms the major bulk of the overall vehicle cost. But it brings significant benefits associated with EV operation, such as the ability to regenerate energy back from braking, and that can be used to recharge the batteries and further extend the range. It has fewer parts compared to combustion engine, thus require less maintenance. And another social benefit, especially in a city environment, is the potential reduction of external noise that will otherwise be attributed from the exhaust and from the engine. So the emphasis here in Scope Electric is how can we have a lighter weight design through more integration of the electronics, more compact and efficient thermal management, so that we can achieve excellent rideability in terms of good handling, comfort, high drive efficiency, reduction in noise and vibration, and thereby better energy efficiency. So as you can see, we have to look at not just on the supply side efficiency, but also how can we tackle efficiency or create more efficiency on the demand side. Now, I'd like to move on to the last area, which is this thing about commonly referred to as connectivity or digitalization. Now, connectivity is about adding a whole new level of digital intelligence in the system, and plays around the emergence of IoT sensors, artificial intelligence, machine learning, serverless computing, and it has helped push capabilities using a data-driven approach to optimize user experience and also to create new business models. So for example, onboard sensors attached to various systems can provide real-time information about the machine performance. You can track the wear and tear of parts and determine when maintenance should be performed. So these systems can give rise to predictive maintenance and even battery leasing models, because the entire battery health now can be tracked throughout its primary use in the electric vehicle, which then gives the ability to better match for a possible second life application. So this can actually generate significant savings to both the manufacturers and consumers and contribute to this notion of circular economy. Now, we can also use external sensors coming from surrounding road infrastructure, buildings, the traffic conditions, and the environmental. These provide very good contextualized or contextual information. For example, you can integrate parking and charging station availability information, which will then allows you to optimize routing and navigation. So this is a key development area for us to develop not only an electric motorcycle, but a smart electric motorcycle. And we have been experimenting and developing our data platform with advanced sensors that will enhance rider safety and also optimize the electric vehicle operation. Now, I would just like to end with this last slide, and I have shared the perspective of an EV designer and manufacturer. And I think the drive towards the future of electric and autonomous mobility requires the involvement of many stakeholders, be it the government, technology, and solution providers like you and me, and also the end consumers. So on the consumer side, including the government, who has the role of best representing the interests of the people, it is imperative that electric vehicle, again, addresses the mobility challenges facing urban cities today. And at the top, there's the need to plan future towns to be EV ready. And we have been doing this, and I'm very happy that the government has been taking a very holistic approach to this. In terms of having the right charging infrastructure, providing incentives to build charging infrastructure, And importantly, how can we integrate more renewable energy into the grid so that we can drive down the grid emission, contributing to the use of EVs. And this will help us to get as close as possible to carbon neutrality. Now, another important ingredient is about creating test beds so that we can understand early how a technology or solution could work or to be implemented, what type of enabling infrastructure that is needed, or if existing infrastructure has to be upgraded. Now, besides urban planning and test bedding, this also needs to be supported by having a more proactive regulatory framework. And that should not impede the progress of innovation and technology development, but at the same time effective in looking out for the public interest. Now, from the technology and solution providers' point of view, I've shared a lot about how we can better harness emerging technology, and we should view EV as not just a standalone vehicle, but as a connected mobility option that can serve both as a public and private transport. And when we are able to apply autonomous vehicle technology, then I think we can truly create a more efficient, sustainable, and a safer mobility as a service for everyone. So I'm really excited. Landscape is really charged towards electric vehicle. I'm looking forward to the launch of our first product soon. And I hope everyone will stay tuned and watch this space. And once again, thank you. And I look forward to all your questions. Thank you.
Thank you, Mr. Tam, for concluding the webinar presentations and giving us insight on the EV landscape through the perspective of two-wheel vehicles. Before we proceed with the Q&A segment, let's do a simple activity. Let us know in a few words, what can Singapore do to shift electric vehicle adoption into high gear? The link to the activity is on screen and also clickable in the chat box. We have a few answers on screen so far. Some of you are really fast. Let's see what we have on screen. More EV charging points, more grants, more infrastructures. We have 15 responses so far. So if we would appreciate if more of you would actually go into the link inside the chat box and key in your answers. If you do agree with what is being shown on screen, you can also feel free to type the same thing as well. So how the word cloud works is if there are more of the same repeated themes, it will actually become larger. So I'm seeing price as one of the larger ones. So there are a few people that typed in price. Yes, Aloysius, I see your answer. More charging points, more concession. So Lawrence, yeah, I think you're talking about price as well. So a lot of people are talking about price. Okay, we'll give everybody more time to key in your answers. Remember, this is anonymous, so we're not exactly looking at who is keying in what answer. For those of you who are unable to access the link, I can see some of you are also trying to key in your answers inside the chat box. More two-wheelers, COE, just for EV, yeah. More chargers. We should be having more answers on screen. Incentives, that's an interesting answer as well. So we'll wait a few more moments before I'll ask our speakers to weigh in on these responses. Okay, we'll give it a few more seconds for everybody to type in your answers. More responses are welcome. We are getting very dynamic answers about taxes, about charging points, about price. Yeah, availability of portable chargers. Okay. Can we have the full answer on screen? So based on what I saw on screen earlier on, it seems like price is the top answer for making electric vehicles gain more traction. So we can continue having more responses or more awareness. That's interesting. Low insurance premium. I see, I see. Okay, evidently, price is the top answer to making electric vehicles gain more traction. So we had many different answers, but price is the top answer. So before we kick the Q&A session, can I invite our speakers to comment on the word cloud results? Perhaps may we have our 4 speakers, Dr. Wang, Jasmine, Olivia, and Mr. Tam. May you turn on your cameras and comment on the poll results? We can get maybe Dr. Wang. Dr. Wang, can you comment on the results? What do you think about the word cloud answers? That price is the top factor.
Okay. How do I turn on the video?
Oh, at the bottom of the screen, there's a video button. Bottom left-hand corner of the screen, you see mute, and then there's the video. So you can actually...
Yeah. Okay.
Huh? Okay, but still...
Okay, now.
So
So about the price,
okay,
I think the battery is the highest price component in electric vehicle. So I think this one we have to wait for the progress of the battery technology. Fortunately, the battery price actually in the last 2 years are sharply reduced. So we can expect in the next 5 years, the price of the battery will further decrease. I think many people believe in 5 to 10 years later, we can see the price of the EV should be cheaper than the ICE cars, because the battery price actually is sharply reduced in the last 10 years, and still maintain this tendency.
Okay, what about you, Olivia? What do you think? Dr. Wang's standpoint was about the battery price. What do you think about these answers on the screen?
Well, I'm not surprised, I suppose. As I mentioned in my presentation, I think there's 2 main things that we are trying to resolve in Singapore. One is really the affordability and the availability of vehicle models, right? So price obviously reflects that. And the other part is really charging. So, I think that when you the day you walk into a car showroom, or maybe online nowadays, right? And you actually see EV models that are on par or even cheaper than a comparable ICE vehicle, I think that's when it really becomes a very viable option for everyone. Right now, the way that it works in terms of the dynamics is really that when you have the slightly higher upfront cost of the vehicle, you actually are able to recoup that through the running cost, because per km on average, you actually pay a lot less for an electric vehicle to be running as compared to if you were using a petrol or diesel vehicle. So there are savings in terms of operating the vehicle. But of course, if you have the upfront cost coming down, such as it's on par or even cheaper, then that would immediately make that EV a lot more attractive. And I agree with Dr. Wang, which is that, we are seeing battery prices come down very significantly, which is why then I think most of the research houses and many of the studies out there have also then predicted that in the mid-2020s, in the next couple of years, we are expecting price parity for EVs as compared to ICE. So I think that's a very positive and very optimistic sign.
Jasmine, what's your take on this? Do you agree with them?
In certain way, I agree with the Dr. Wang's point of view. Again, but from a car retailer point of view, it's about demand and supply. Because right now, for me to reduce the car of my EV car, I need to commit a certain. Singapore is a very small market. We must always understand, compared to a lot of international market that currently is operating. So the only way to reduce the car size is to actually have a minimum MOQ or commit to a certain volume as far as the EV is concerned. So when you do that, definitely the car prices will be more better than what it is. Because if I look at the trend, hybrid used to be a lot more expensive because of the massive adoption and also because of the growing volume. The cost is becoming better. Likewise, the same will be the same for the EV, and also it also depends on the maturity of the battery technology. Because the battery technology is evolving very fast, and now there's a lot of conversation about solid-state batteries, and all these are actually going to change the way the cost of the car is being manufactured. And in the EV car, the cost of the battery is actually the main component of the car cost. So every as the evolution happens and the way the charging infrastructure happens, this will also reduce the cost effectively. But it takes time because the people it takes time for this thing to come together with the people's lifestyle adaptation versus the infrastructure as well as the technology changes to reach an equivalent point. And I think that will take some time to make it happen.
I see. Okay, Mr. Tam, maybe you can weigh in on this, maybe from an angle of the two-wheel vehicle landscape.
Sure. I think I echo what Oliver mentioned. I think when we look at price, we have to look at the total cost of ownership. And that is also looking at upfront costs as well as operational costs, right? And I think the benefit of EVs is definitely you have lower maintenance. You can generate a lot of savings in terms of maintenance and operation of the fleet. So I think from a total cost wise, right, there's definitely an advantage for electric vehicles. And on specific components like batteries, I think the speakers here have already weighed in. And we are also beginning to see that battery prices are beginning to fall. Some are saying that, or Tesla has been saying that once battery reach about US $100 per kilowatt hour, there will be parity. And you have seen right now even Tesla vehicles, right? Model 3s, they are already very competitive prices in Singapore. So I think this is the price of total upfront cost in terms of battery cost. I think this will definitely decrease over time. And I think it's not just current technology, but the future technology will even make this even more compelling case. So the battery cell technology now has so much investment going into it, and it will definitely improve over time. And this whole thing about cost and ownership will make it very compelling for all the end consumers.
I see. With our four speakers all very optimistic about the price going down, I think we are on a very optimistic start. So now let's take questions from the Q&A box. I see that everybody has been sending a lot of questions into the Q&A box, but for the interest of time, we will keep to different themes to have an even spread of the different questions. So may we have the first question on screen, please? Okay, let's give it a few moments before the questions are shown on the screen. Maybe while waiting for the questions to be shown on screen, maybe I will read out the first question. That is the top voted question. Electricity as a sector seems to be on the second highest greenhouse gas emitter. So how does adopting EV help in reducing carbon footprint? The EV needs to be charged using electricity. Maybe Dr. Wang, can I get you to start the ball rolling on this question?
Okay. Actually, this one we have to consider the energy efficiency. EV has the very high energy efficiency, but the ICE car, the energy efficiency typically is only 20%. About the EV, according to Tesla, they claim the energy efficiency of their car is more than 80%. So another thing is, if you refer to the a website for the Singapore's EV Association, they actually has the data they set according to their data. So if the grid, the emission factor is lower than 800 grams per kilowatt, then use EV will benefit for reducing the emission. In Singapore, the grid emission factor in Singapore is about 419 per kilowatt, so much more lower than the 800 gram per kilowatt. So use EVs, even we get the power from the power grid, even the power is generated in Singapore situation from the national natural gas, but we still can reduce the emission largely. And if the grid use more and more renewable generation, like the Singapore's target, we will get more and more the solar power or other types of the renewable energy, then the emission factor, the emission factor of the grid will get lower and lower. So in that case, we get more benefit from the EV adoption, I think.
Okay, I see. Okay, maybe we'll get Olivia to weigh in on this question. The question is on the screen actually. So now now we have the slides on. Great, thank you. So can we have Olivia to answer this question as well?
Yeah, sure. So I think, Dr. Wang's covered quite a number of the considerations. I think it's quite clear to everyone that EVs are only as green as the source of electricity that they're running on, right? I think fortunately in Singapore though, we already have more than 95% of our generation coming from natural gas. So yes, natural gas is still a fossil fuel, but it is the cleanest option out there. And so that actually allows us to have a decently clean energy mix. The other part, I think that's been very good efforts that are going on is really that we are also increasing the mix of renewable energy into our energy mix in Singapore, right? So I think there has been a lot of efforts to put in more solar into the grid, right? So I think if I'm not wrong, they're going to be quadrupling the solar deployment by 2025. So that's going to be a significant part of the energy mix. I don't think that there's going to be a perfect solution for Singapore because as a nation, we are short on land. We don't have a lot of space. So we can't have huge solar farms like many of the other countries. But we are, I think, doing whatever it takes and whatever we can to then also green the energy, the electricity mix in Singapore as well. In addition, I think there are actually some studies that have been done in terms of electrification, right? So we know that if actually all of the vans and light goods vehicles are actually converted to electric, that's actually going to give us a reduction of 1.5 to 2 million tons in emissions every year, right? That's about 4% actually in terms of our total national emissions. So it's small, but it's not insignificant. I think it's something that we have to work on. And right now we are actually putting in place the solutions that we think that are the best that are available to us. And then over time, I think the energy mix will also continue to improve.
Okay, that's a great answer. We'll move on to the next question. The next question is regarding safety. Can we have the next question on screen, please? Maybe before the question is being posted, I will read the question first. Maybe we can think about the question. So are there any industrial standards that battery packs and internal chargers used in EVs have to conform to in Singapore for safety and reliability? Maybe in terms of safety and reliability, I will get Jasmine to comment on this.
For EVs or EV batteries, I think we have to go through a very strict test. I think in Singapore, in fact, Singapore is one of the strictest, especially with the Singapore fire hazard, as well as all the so-called, the LTA, when they do the homologation. This has been one of the key factors when they look at for battery packs. But having said that, no matter how they conform to the safety and reliability, the truth and the reality is that when the EV battery catch fire, if there is a different procedures of making sure that we take care of it, because EV fire is not like normal fire that can just use water and just get it over with. It still could be a hazard. I think more importantly is also not about the safety and reliability, which I'm sure in every OEM which we have for Toyota, we are absolutely top-notch in making sure that we conform to the global standard. But we are also making sure that the education of the public is, they are also well aware what needs to be done when they reach a certain situation whereby they put themselves on risk because of EV battery. And it is still in many, many countries. You have probably heard about Tesla got into a fire, and you probably heard about people die because of that. I mean, in any case, it's still something that we always try to put in a lot of regulation inside, but there's always this human factor that need a lot more education to be well informed to make it safer. Yeah.
I see. Sean, Huang Shong, what do you feel about this answer as well? Are you together with this statement?
Yes, of course. I mean, there are definitely a lot of industry standards. Even as we speak, as we are designing our electric motorcycle, we are also going through a lot of safety homologation standard testing that is compliant to European standards, right? So by and large, Singapore tend to adopt a lot of international standards, that is either European, Japanese, or American standards. So there's a lot of stringent tests in terms of the battery requirements, in terms of electrical safety that needs to be actually follow a certain guidelines and regulations. So I definitely agree with what Jasmine mentioned. I think there's also a educational aspects, right? You should also have to educate the public in terms of what you should do and what you should not do, right? Like, for example, we have a lot of electric PMDs, right? They're charging at home, and today, there's a lot of potential fires that catch. So I think there's a lot of public education, but at the same time, from manufacturer point of view, the automotive industry is definitely a very stringent testing, safety regulations that we go through. So without a doubt, there are definitely stringent tests.
Yeah, education is very important, and I think both our speakers have actually weighed in on that. And it's very interesting that you mentioned about PMDs, because I believe maybe the person that wrote the question down had this in mind before they asked the question, because there were a few PMD fire burning incidents. Okay, so the next question we have on screen is, are there any industrial standards, as an incentive for going electric? Will there be differences on COE and road tax between EVs and regular cars? Will there be a tax break for electric cars? This is the question that we have been seeing on screen, and during the word cloud, everybody's talking about price. So maybe I will get I'll get Dr. Wang to comment on this first. So Dr. Wang, would you like to comment on this?
Actually, Oliver just now in her presentation has mentioned this. I think she should be able to answer this question better.
Okay, give me a moment, sorry. Okay, maybe Olivia, would you like to, maybe you can get the ball rolling on this question?
Well, I suppose I can only represent what is currently available, right? Obviously, if there are going to be additional policies or different types of incentives that are coming, I think that's completely up to our friends in the government to actually think through what it makes sense, right? But as it stands today, there is already an early EV adoption incentive, right? So like I mentioned, that gives you a 45% rebate on ARF up to 20,000. There's also a vehicular emission scheme. So it basically measures the amount of emissions that comes from the vehicle. And depending on how good your vehicle performs, you are able to then get different types of rebates. And full EVs actually get 25,000 rebate for that. There's also a commercial vehicle emission scheme. So that's specifically for vans and for commercial vehicles that are used for commercial purposes. So in those cases, you also get 30,000 for a Band A vehicle. And like I mentioned, I think there have been some changes to the road tax that are quite detailed. So I don't think I can sort of do it justice here at this platform. But the changes to the road tax actually have tried to make the EVs be closer or more on par with ICEs, such that you're actually not being penalized for actually having a very fast pickup, as they like to say, just because there's a sort of a different measurement for ICEs and EVs. So yes, I think there are, as a quick sort of summary in a nutshell, there are incentives for doing these things as it stands today. And again, up to the government authorities to see whether there's going to be anything further that is available in the future.
Okay, Jasmine, do you have more details on these incentives?
I think we need to differentiate the fact that COE is to control the demand and supply of the car on the road. And the best way to reduce emission actually is to have car light, less car and use public transport. So the whole COE system has been used to regulate the demand and supply, because whether you are EV or not, you still move, you still car on the road. So I don't think COE should be mixed into this conversation, because it's a demand and supply tools to regulate the car population in Singapore. And the recent tax break, as well as the stringent BES, is already a breakthrough to make sure that there is enough so-called adoption rate for the people to actually go for EV. And I think that should serve the purpose, because ultimately what you want to have is the fact that the EV is about cleaner emission, and only cleaner cars enjoy the tax break. So I think the BES serve as that purpose. And I would say that that's more than enough. I think we shouldn't mix it with the COE, because COE helps to regulate the supply and demand. And Singapore being a small country, small place, too many cars will have a different problem. In the end, if you have a lot of EVs, and you might end up clogging, we have a different issue totally for car populations. Yeah.
Okay, Sean, do you think there will be a tax break for electric motorbikes?
I hope so. I mean, definitely, I mean, looking at what the incentives are right now covered for cars, I hope the government will also extend this for two-wheelers and motorcycles. This is something that I think we will be actively try to lobby and try to request, right, in terms of extending this tax breaks even for motorcycles.
Okay, so we will move on to the next question. We will have it on screen in a few moments. Is it possible to provide quality electric motorcycles at lower cost of entry, adequately affordable to those of a lower income group, yet with solutions in place such that they do not face income debilitating charging or repair downtimes? This question is asked on the context of those who work as food delivery men or package couriers. So I think this question is more tailor-made for Mr. Tam.
Yes, quality is very, very subjective. So I think what we are focusing right now, of course, is a very high performance premium product. Notwithstanding that, I cannot go into much details. We are also exploring possible products for commercial fleet that will be much used for, delivery service, for courier or logistics type. But then again, I think in my presentation, I covered that, one of the different infrastructure, charging infrastructure will be very different, because for logistics and delivery, they have a very different charging needs in terms of needing to have a faster turnaround solution. And so having stationary or just purely public charging stations in terms of coverage itself, and given that battery technologies cannot say do too fast a charge because there will be degradation in terms of the battery cell life, then there might be other solutions that we have looked for in terms of battery swapping, which will be very useful for this fleet operation. So I think in totality, it's not just the vehicle itself. I think in the space of electric vehicle right now, as a designer and manufacturer, we also have to look at the whole ecosystem, which the charging infrastructure is part of it.
I see. Okay, let's look at the next question. Will a large-scale adoption of EVs lead to a change in the way ventilation systems are designed in a multi-story and underground car parks? So this question is quite interesting because this is more infrastructure-based. We probably get Dr. Wang to weigh in more because he used to do more research on all these EVs. Dr. Wang, may we have your answer to this question, please?
Because the adoption of EV will not generate any gas, and the only thing is if more EV charging at the same time, whether it will generate more heat or not. I think because in Singapore, most of the car park actually is open. So there should be no problem. But if in a closed room, if there are more EVs charging together, they generate quite large amount of heat, then the ventilation system, of course, need to be considered about this. But for the underground car park, if the car park is large enough, I don't think there should be any problem, unless the car park is the underground car park is quite small, so may generate and use the fast charging in a car park. But actually, in a car park, I suppose in a residential car park or the office car park, we just use the AC level 2 charger. So in that case, the power is not so high, will not generate too much heat. But if you use the fast charging technology in underground car park, may generate quite amount of heat. We have to consider this because one charger for the fast DC charging station, the power may be more than 200 kilowatts, just one charger. So in that case, we have to consider this. Okay. So it depends on what kind of charger used. Just the level AC level 2 charger, I think this is not a problem. But if you use the fast charging, use the DC fast charging charger in underground car park, if you use more this kind of charger, definitely the ventilation system need to be considered.
So the type of charging method actually is very important, right?
Yeah.
So okay, so Olivia, would you like to comment on this as well, since SP is providing a lot of the electric charging components?
Yeah. So I think, at this juncture, obviously there's no issue, right? Just because the number of EVs is not high, and on average, we only have a handful of chargers in each of the premises. I agree that there could be a little bit of heat that's generated, but I think it also then depends on how the configuration of the network then evolves, right? At this moment, in many of the buildings, it's actually difficult to find a location that actually has enough power to support 200 or 300 kilowatts, right? So most of even our fast DC chargers that we have installed typically are 50 kilowatts. So they are fast, but they are not, at the sort of ultra fast scale at this moment. So I think it will be sort of a mixture of a couple of different factors. I think Dr. Wang also alluded to this. You actually have a lot less tailpipe emissions. So in terms of ventilation for that particular purpose, it may sort of go away, that requirement. And then I guess what's to be considered is really the amount of heat that is generated in terms of some of the chargers as they are being installed. Another technology actually that isn't available in Singapore today yet is actually liquid-cooled cables. So actually, the reason why you actually need liquid-cooled cables is because when you have a high power actually running through a cable that transmits electricity from the charger to the vehicle, you actually generate heat, right, in that process. But when you actually have a liquid-cooled cable, you sort of mitigate that issue. So I think there's sort of a number of considerations ongoing right now with TR25 and some of the regulatory requirements. But I think that's also another way that will actually reduce some of the heat that's being generated in the charging process.
So can I further clarify, as long as the heat is being managed, then the ventilation systems designed in our underground car parks can just remain the same? Is that what you are saying?
Well, I'm not a building expert, right? So I'm probably not the best person to answer about the building design and so on. But I think what I'm saying is that from the charger perspective, where we are going to a higher speed charging and the equipment is then we foresee that actually the chargers actually will generate quite a bit of heat, then there are other mitigations, and the design of the equipment is actually being taken into consideration in order to mitigate the heat generation.
So the design of the equipment is actually a very key component among other factors as well. I see. Thank you. So let's move on to the next question. If we can have the next question on screen. This question is about battery pack disposal. How do we solve the battery disposal issue? Batteries can only last about 5 to 8 years without proper discarding. It may leak and cause environmental issues. Can we have Jasmine to comment on this, please?
I think this is a very important question because, like, for us, what we're doing right now is that we're actually working actively with the government-appointed agency called ALBA, whereby it's an e-waste management initiative, whereby we could potentially start in July this year for the collection of the used battery in our workshop. And then this will allow us to actually do an e-recycling. So this is a kind of sustainable movement that is becoming increasingly important for our organization. So one of the initiatives is that when we sell the EV car or hybrid car, we are going to encourage our customer to come back to our system, so that whether during their after-sales services or when they want to so-called sell off the car, they will just take back the battery to do a recycling process. Because this is to me, to my organization, we took that very seriously, because Toyota also take that seriously, because battery disposal is a very important part of environmental concern. So as a so-called auto, as a responsible auto player, we need to be responsible for that. And I think currently there is already a lot of discussion base, and we'll see this business starting out in July potentially. Yeah.
I see. Okay, Kwang Shong, maybe you would like to comment on this as well, about battery disposal and discarding?
Yeah, well, I don't have much to comment, but indeed, I think this is a very important topic about e-waste. Disposable is one, recycling is another one. But recycling for battery gets very tough, especially if the battery packs are sealed. So I think this is a very, very important and pressing. Likewise, as a electric vehicle manufacturer, we have to tackle this as well, looking at how can we work with partners as well as the government in terms of how can we get disposal, and also looking at maybe the design of the battery itself. We have to look at what can be recycled, what can be serviceable. So there are also on the design side that I think we could also explore in terms of how to reduce some of this risk, downside risk.
Okay, great. Yeah, it's good that we consider environmental issues and recycling and what parts can be recycled. But let's, for the interest of time, we will move on to one final question. So let's have the final question on screen. EV adoption is in Singapore. It's still in the early adoption stage. Even with strong government push for EVs, to own an EV is really too expensive compared to the conventional ICEs. Despite the strong industry support, the EV adoption rate in Singapore is still slow, mainly because of the high price tag that needs to be borne by vehicle owners. Crossing the chasm to the early majority stage is a huge challenge, as we need to deal with the delicate balance between allowing too many cars on the road and at the same time pushing to have more EVs on road. How confident are industry players with finite resources that you will be able to pour in resources to push for EVs at the same time survive the chasm? So if I may, can I have Olivia to begin with this?
Yeah, happy to take that. So I think I mentioned earlier in my presentation that actually SP got into this business, and we committed to starting this journey even way before there was any commitment from the government, even way before maybe some of the environmental conditions became more conducive for the adoption of EVs. So I think our position has always been clear. We want to be committed to the future. We know that it's going to be coming. It's just a matter of time. And we also play a key role in helping the acceleration of the adoption, right? So as the more charging points that we're able to put on the ground, the better it becomes in terms of assuring users and fleet owners that the infrastructure will be ready to support their fleets and to support their vehicles. So, we believe in the future, but we are also playing that role to try to accelerate that. So I think for us, it's very, very clear. We've committed to it. We will continue to be committed to it, and we want to be a very significant part of this industry moving forward.
Okay, would Inchcape like to comment on this, because there are a few company names, SP, Inchcape, and Scorpio. So we will go in the order of this flow, and maybe we can get Dr. Wang to wrap up with his additional opinions on this. So Jasmine, can you share your opinion on this?
I think EV adoption is a process. That's the reason why at the end of the day, it's a consumer choice. We have to respect the consumer choice and their readiness to adopt the EV. I think what we can do is to provide as much information, education, as well as choices as available. And I think we need to be mindful that in every transition, there's a so-called in-between state. If you are already so used to ICE, to jump into the EV, it might be so difficult because you're kind of nervous about what's battery all about. I think hybrid is a good interim solution. And when they got more confident, they will go for the EV adoption. And hybrid at this moment is actually part of the green plan. And it's also a form of electrification. Of course, it's actually 14 more time inefficient using the same amount of resources, but it allows the adoption, and I think that's the reason why it was labeled as part of the adoption, and there's some incentive drive to actually promote hybrid as well. And then and this will be in time when the infrastructure is being built up, people getting more comfortable, and I think it will just go as the speed will happen, because as more and more people adopt EV, it will actually address some of the anxiety that people are having right now. And also to change the lifestyle also takes time. So I believe that eventually it will happen, but we need to take the first step. So by having options and available for the customer is really the first step. And by the fact that the government providing incentive is really the first step. But more importantly is the people prepared to change their lifestyle? Because having EV is about lifestyle changing. You have to plan your charging mode, you have to plan the way you go about your route. And it's about lifestyle. I think that's more important. And as time passes by, it will eventually happen.
Okay. What about Kong Shong? Do you have any?
So as Scorpio, we are of course a startup, and indeed startup has finite resources, but we are totally fully committed to this endeavor about electric vehicle. And I mentioned earlier in my presentation, choosing electric vehicle, the reason for choosing electric vehicle must be the reason for choosing a sustainable future. I think that has to be clear in terms of, from user perspective, that mindset change has to be there. And then once you have the mindset change, then how do we deal with all these challenges? I think this is the technology, the solution provider, the governments all will come in, chip in to look at challenges that we can reduce the entry or barrier. How can we improve further efficiency, the price points of the vehicle? I think that will shape eventually, right, into something that will materialize. But I think for the first hurdle, as an end consumer or user, we have to get this mindset change that EV is here and EV is here to stay, and we have to move into this new form, right? And supporting a sustainable future. I think that has to be the way to go.
Okay, so maybe to conclude this question, maybe I will angle the question a little bit. Maybe for Dr. Wang, what is your opinion on us being able to cross the chasm from our normal ICE vehicles to having more EVs on the road?
Okay, I think sorry, we have the seminar. I think the government still control the total number of the vehicles in Singapore by using the COE. So actually the purpose of the government is not to introduce more vehicles in Singapore, but change the ratio, EV versus the ICE car, change the ratio. More and more the cars are EV, not the ICE car. I think the total number of the vehicles still controlled by the government through the COE. Yeah.
Okay, yeah, we agree that the COE is the limiting factor, as mentioned many times in our Q&A session as well. So unfortunately, this is all the time we have for the Q&A session. Hopefully, you've taken different aspects of the questions in our Q&A list. Once again, thank you, Dr. Wang, Olivia, Jasmine, and Mr. Tam for taking our questions. We definitely benefited from your expertise and knowledge. We also thank everyone for your active participation and enthusiasm. We will review the questions that didn't manage to get addressed and will put together a consolidated response to be shared with all attendees after webinar. Ladies and gentlemen, we have come to the end of today's webinar. I hope you have received much knowledge from our speakers this afternoon. Before you leave, kindly help us to complete the brief feedback form so we can improve our delivery for the next webinar. If you have further queries or would like to connect with either SP or SGBC, you can write into us at these email addresses on screen and follow us on our social media platforms. Lastly, stay connected with SGBC through our various communication channels and stay updated on industry news, updates, and SGBC events. If you are interested to attend more webinars related to green building and sustainability, do join us for the next SGBC webinar on financing renewable energy integrations next Thursday. The link to the registration is in the chat box. With that, I wish everyone a wonderful and productive afternoon ahead. Thank you.